All right, this video is for Learning Target 2, which is a continuation of counting techniques. In Learning Target 1, we learned the fundamental counting principle, a way to count multiple events, a way to count multiple things. Learning Target 2 deals with permutations and combinations, and the difference is when order matters or when it does not. All right, now what we're going to do is, before we even get into does order matter or not, which is a very confusing topic, we're going to refresh our memory or learn something new, an exclamation point, such as 3 exclamation point. It's called a factorial, and I'm not sure if you've ever seen this before or not, but a 3 factorial literally means 3 times 2 times 1, so it's the number 6. So number 1, a 5 factorial would be 5 times 4 times 3 times 2 times 1, which is 20 times 6, 120. The reason we're studying the factorial, the exclamation point, is because our permutation and combination formulas involve the factorial. So let's take a look at another one, number 2. 10 factorial. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 8 factorial. 8 times 6 times 5 times 4 times 3 times 2 times 1. In a fraction, a lot of these numbers are going to cancel. 8 and 8 are going to reduce to 1. 7 and 7, 6 and 6, 5 and 5, 4 and 4, 3 and 3, 2 and 2, and of course 1 and 1 already reduces to 1, leaving us with only 2 numbers, 10 times 9. So 10 factorial divided by 8 factorial is just 90. All right, so number 3, if I were you, I'd pause the video and maybe try it yourself. Notice the 12 factorial and the 8 factorial. The 12, 11, 8, 7, 6, 5, 4, 3, 2, 1. And the 8, 7, 6, 5, 4, 3, 2, 1 are all going to, whoops, I didn't write that right. Let me try that again. The 12, 11, 10, 9, 8, 7, 6, all the way down to 1, divided by 8 factorial. All of the 8, 7, 6, 5, 4, 3, 2, 1 are all going to cancel, meaning 8 factorial is going to cancel the 8, 7, 6, 5, 4, 3, 2, 1 factors of the 12 factorial, leaving you only with 12 times 11 times 10 times 9. There's still a division of 4 factorial, so 4 times 3 times 2 times 1. So if you write that out, you end up with, well, 4 times 3 is 12. So that reduces. And 2 and 10 reduce to 5 and 1. So that's 11, 5, 9. 11 times 5 times 9. 11 times 5 times 9 would be, let's get the right feature going here, 11 times 5 times 9 be 495. So we know the answer is 495. Now let's see how to do this in the calculator, because of course we paid $100 for a calculator. It better have this feature. So where is the factorial feature? In the same math menu where you have reduced your fractions, over to the right in the probability menu, you notice there's a factorial in the 4th option. So that's the button. I'll quit that. That's the button we're going to use. 12 factorial. So 12 math PRB, 4th option, divided by 8 factorial times 4 factorial. Well, make sure you open a parenthesis for your 8 factorial times 4 factorial. Then you close your parentheses to make sure you trap both of those divisions, both of those things being divided. And hit enter, and we should get, yep, same answer, 495. So while you may have noticed in the probability menu, there was also an NPR, NCR feature. We will use those eventually as well. Those are, the P and the C's stand for permutations and combinations, but in due time. Now, all that factorial discussion was so that we can use that when we're calculating our permutations and combinations. Let's look at an example. Number 4, with a 7-class schedule like yours, how many different ways could your classes have been arranged? Assume that all classes are offered every hour. Does order matter? If you say yes, order matters, it is a permutation. All right, this is one of the trickiest things that I teach all year. It's tricky for me to explain, so I've got a couple different options, really just the two options, of trying to determine that. And it's also further compounded, the confusion's further compounded by the fact that with permutations, there's a lot of overlap with dependent events, which we'll talk about later. Right now, let's just focus on the order mattering or not. So, to test if order matters, test by selecting your outcome. Then select the same outcome in a different order. That's the key word to find out if the order mattered. So for our example, 7-class schedule, picture your 7 classes in your head right now. You have math first period, algebra 2 first period, you have whatever you have. All right, so you've got that outcome selected. So we're selected our outcome. Now select the same outcome. Select the same 7 classes in a different order. The easiest way would be just switch your first and second period. Is that a different 7-class schedule? Different 7-class schedule. Yes, it is. Yes. So if that's a different 7-class schedule, then order mattered. And the way, if order matters, it's a permutation. You count permutations using n factorial if you're going to use all 7 classes, which you are in this example. So 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1, which gives you 7 factorial, gives you 5,040. There's a little bit of overlap here. Sorry, there was a little bit of an announcement there. Back to where we were. There's a little bit of overlap with factorial, 7 factorial, and when we did dependent events, because you could view this question as picking a class, a first period class, out of the 7 you have to use, and you'd have 7 options. And as soon as you say, I'm taking math first, or whatever you say out of those 7 classes, you only have 6 options left for your second period, then 5, then 4, and so forth. So there's some overlap here with when order matters with dependent events. All right, moving on. 8 people enter a Best Picture contest. So they've been taking photographs, and now they're going to get a first, second, or third ribbon awarded. Does order matter? Back to the test. Test by selecting your outcome, then selecting the same outcome in a different order. So I will just use fictitious people. We'll say John, first place, John. Second place, David. Third place, Roger. Does order matter? Well, if I pick the same 3 people, because the test says pick the same outcome, select the same outcome in a different order, I'll pick the same 3 people, but I'll put... Sorry, again, we had another announcement there. If I put them in a different order, then Roger first, John second, David third. Are they getting different ribbons? Yeah, Roger's getting first place now. John's getting second place. So order matters. But notice that there were 8 people, and you're only awarding 3 ribbons. So when this is happening, you're not using all 8 people. It's not 8 factorial. There's a formula for counting permutations taken R at a time. The N stands for the 8 people. 8 people. Permutations taken 3 at a time. The 3 is how many awards you're giving out. So the factorial formula says 8 factorial over 8 minus 3 factorial, which is 8 factorial over 5 factorial, which is 8 times 7 times 6 times 5 times 4, 3, 2, 1, over 5 times 4 times 3 times 2 times 1. The 5, 4, 3, 2, 1 all cancel, and you're left with 8 times 7 times 6, which is 8 times 7, oops, wrong button, 8 Let's see if I can get this to work. 8. There we go. 8 times 7 times 6, 336. So 336. Number 6, moving on. I want to wrap the video up for you. 5 cousins at a family reunion decide that 3 of them will go pick up a pizza. How many ways can they choose 3 people to go? 5 cousins, 3 people. Does order matter? All right, again, I'm going to pick John, David, and Roger. I'm going to pretend they're cousins. Then I'm going to pick the same people in a different order. Roger, John, David. Does order matter? Do you get a different group of 3 people going to get pizza? No. John, David, Roger. John, David, Roger is the same thing as Roger, John, David when you're talking about taking 3 people to go get pizza. So order does not matter. When order does not matter, it's a combination. And combination has its own formula, and it's very similar to the permutation formula. It has how many you have to pick from, 5 cousins, choose 3. The formula says take the 5 factorial and divide it by parentheses 5 minus 3 factorial times r factorial, which is 3 factorial. So you have 5 factorial over 2 factorial, 3 factorial. We'll do this one in the calculator to finish it because we can, and I can use that to show you where the buttons are. 5C3 is input in the calculator by hitting 5 first and going to Math, over to the probability menu, the third option, hit enter, and then hit 3. And the calculator is interpreting the 5 as the N and the 3 as the R, and it's plugging it into the formula you see behind the calculator here, and it gives you the answer 10, which we were so close to getting the answer 10 already over here. 3 factorial is going to cancel the 3, 2, 1 from this 5 factorial. We were going to be left with 5 times 4 over 2 times 1. We were going to get 10 anyway. But as you can see from the calculator, you get 10 either way. Make sure you don't abuse the calculator and use it all the time, because there will be questions that you have to use the formula. The formulas are, like it says here, on the blue sheet. They're on your formula sheet that you get to use at the end of the year, on the end of course. So you got to know how to use those there too. The final problem. 5 cards are drawn from a standard deck of cards. How many hands are possible? Does order matter? We'll keep this simple. Ace, king, queen, jack, 10 of hearts. In that order. Our test says choose the same outcome in a different order. Did it matter? All right, so this time, instead of getting ace first, I'm going to say 10. All right, sorry again. Picking the same outcome in a different order, 10, jack, queen, king, ace, all of hearts still. Did that matter? Did I get a different 5-card hand? No, no. So order didn't matter. So this is a combination. There are 52 cards in the deck, so 52, C5. We'll let the calculator calculate that monstrous number. Let's see, erase. 52, math C. 5, 2,598,960. All right, I will leave you in the video with this thought. We won't do any further than the 11, but state whether these are permutations or combinations. Number 8, if you will want to pause the video right now. If you would like to try these 8, 9, 10, 11, just decide if order matters or if order does not. You would want to pause the video because I'm about to give the answers to all 4 and try them yourself. So pause it now. All right. Number 8, committee of 4 juniors, and you're just going to pick a committee of 4. It doesn't matter what order. This is a combination. If you pick the same 4 people in a different order, you have the same committee. If you change number 8 to say president, vice president, secretary, treasurer, then the order would matter because when you put a person first, they're president, but if you put them last, they're treasurer. I'll use this example to kind of illustrate my other technique to explain if order matters. If this problem, number 8, is as it's written, pick a committee of 4 juniors, does it matter if you put John here or if you put John there? Will it change your 4-person committee? No, it won't. So order doesn't matter where you put that person. But as soon as you call this the president, and this the VP, and this the secretary, and this the treasurer, it matters where you put John. So the order matters. Number 9, 3 library books out of 8. It doesn't matter what order you pick the 3 books. As long as you pick the same 3 books in a different order, you're walking out of the library with the same 3 books. Combination. First, second, and third place finishers in a 10-contestant race. As soon as you pick a first, second, and third and switch the order, you get a different outcome. So order matters. Here's another way to see that. 3 boxes. Pick a first place winner. First place is this box, second place is this box, third is that. Does it matter where I put John this time? Does it matter what order I pick John? Sure, he gets a different award if I put him in a different box. So this is a permutation, P. The last one, 2 students to go to Dairy Queen and get ice cream. Does order matter? No, if you pick the same 2 people in a different order, you're still sending the same 2 people to go get ice cream, so combination. And that's all I'll go through in the video for Learning Target 2.